Hello everyone, welcome to my channel. In the previous video, I did look at integrals involving radical functions. In this video, I would like to continue looking at integrals involving radical functions, and I have four integrals that I want us to look at. So our first integral is this one, the integral of the square root of 2x plus 7 dx. So we're going to use U-substitution here as follows. First, let me capture the integral exactly how it is. The integral of the square root of 2x plus 7, and we have dx here. Now, at this stage, we're going to watch this, u squared be equal to 2x plus 7, because we have a square root sign there, so I want to use u squared. Differentiating both sides, we have 2u du, this will be equal to 2 dx. Dividing both sides, cancelling the 2, we have u du equals dx. Now, we bring this expression there and this one there, and we carry on. So this integral changes to the integral of the square root of, remember now we have u squared there, and then in place of dx I'm going to have u du. Now what is this? This is just u, so this is the integral of u times u du. This is the integral of u squared du, and obviously you can agree with me that this is u cubed over 3, and then I have to say plus c. But now we must move back and say what is u. From here you can clearly see that u must be equal to the square root of 2x plus 7. And what is the square root of 2x plus 7? You agree with me that this is exactly the same as 2x plus 7 all to the power half. This is more important because we're going to need it here. Now, let's move to page 2. This is page 1. Page 1. Let's move to page 2. On page 2, I'm basically saying, let me move this one down a little bit. Right, I'm basically saying that now we have, in the place of u cubed, we're going to have 2x plus 7 all to the power half. But remember, there's a power of 3 outside, and of course we are dividing it by 3, not 2. My hand is misbehaving there. I just need to get rid of, this part here, because we're dividing by 3 there, as you can see, and we have to say plus a constant. Now simplifying this, it will be better for us to write 1/3 of 2x plus 7 half times 3, it will be 3 over 2, and then plus c. So this is our final solution to our first integral, and this was our first integral over here. You can see it here, very easy to deal with, and that's our final solution, right? So let's move on now to page 3. Let's look at the second integral. Page 3, here is the second integral. There it is. We're supposed to integrate 3x over square root of x plus 3 dx. Again, U-substitution is the way to go. Number 2, let me capture it exactly how it is. The integral of 3x all over square root of x plus 3 dx. I'm again going to say let u squared be equal to x plus 3. And because we have x up there, it's going to be necessary for us to solve for x here. So you can agree with me that x is actually u squared minus 3. Right, but we have to differentiate both sides. So differentiating this both sides, we have 2u du equals dx. So now this integral then changes to the integral of 3. What is x? X is u squared minus 3. And we're saying all over square root of, what is x plus 3? U squared times, what is dx? 2u du. Right, check the 3 out because it's a constant. So we have 3, the integral of, obviously it's 3 times 2, but let me keep it for now. I'm going to take it out also. So what we have now is u squared minus 3 all over this obviously is going to be u times 2u du, and the u's cancel, the 2 must come out, so we have 6, the integral of u squared minus 3, and then we have du. Right, so this we can perform integration straight away. This will be 6 like this. The integral of u squared is u to the power 3 over 3 minus the integral of 3 is just 3u, and then we have to say plus a constant c. Now let's simplify this. Distribute the 6. That takes us to page 4. Page 4. Distributing the 6, what we get is 6 times this expression here, it's going to be 2u power 3 minus 18u, and then plus c. But we have to go back and say, what is u? Right, going back here, again, you can see here that u actually, if I move straight and I'm going to say u is basically equal to x plus 3 to the power half. That means square root. Remember that. I come here and I say this is the same as 2x plus 3 to the power half, but I have a power of 3 outside, and then minus 18, and then x plus 3 to the power half plus c. Simplifying this part here, you agree with me that this is going to be 2x plus 3 to the power 3 over 2 minus 18 x plus 3 to the power half plus c. So that is the final solution to our second integral in this video. And our second integral in this video, if you agree with me, it's actually this one here, up here. Right. So we can now move on then, because that's our second integral. From our original page, that's the one. That's the one. Now let's move to our third integral now. Our last page was page 4. Now I'm moving to page 5. Page 5. I have the third integral here. There it is. Similar to the one we've gone through. But you know, going through as many of these as possible helps you build confidence. So again, we're going to use U-substitution here, but it's a little bit involving now, but yeah, let's carry on. So let me capture the integral number 3. It's the integral of 2x all over square root of 3x plus 5 dx. Now again, I'm going to let u squared be equal to 3x plus 5. Following the same routine, solving for x here will not be very straightforward. Subtract 5 from both sides. U squared minus 5 equals 3x. Divide by 3 both sides, it gives you x equals u squared minus 5 all over 3. Let's put this one in a rectangular box. We're gonna need it at a stage. But meanwhile, let's carry on with this one. Differentiate both sides. You're gonna get 2u du is equal to 3 dx. Divide by 3 both sides. You're gonna have 2u all over 3 du equals dx. Now this is that one there. It means this expression must come in there, and here I will have u squared there, and then up there I will have 2 times this expression. So now this integral then changes to, if you like, the integral of 2 open brackets. What is our x? Our x is u squared minus 5 all over 3 and all over square root of, what do we have in the denominator there? This whole expression is u squared, so that's u squared times, what is dx there? It's 2u du all over 3. Quite a lot of stuff to take care of. 2 times numbers that are multiplying. 2 times 2 is 4, must come here. This 3 is dividing and that 3 is dividing, so that will be 9. So it will be 4 over 9 outside. So that's page number 6 now. Page 6. What are we saying? We are saying that if I move this one down a bit, all right, now I'm saying that we have 4 over 9 outside, and then the integral of, remember these two are dividing, take them out. 3 times 3 is 9. 2 times 2 is 4, right? And what do we have? Of course, this cancels. Let me move it down. This here cancels that. So, and I'm going to have u there. And if you like, this u cancels that u. So now what do I have inside here? What I have inside the integral sign there, what I have now is going to be u squared minus 5, and this has to be in brackets like this, du. Hopefully you can catch that. The 2's are multiplying. Here it's 2 times 2, 4, 3 times 3, 9, and then this u cancels that u. So what do I have? I have this expression. Remember, the 3's and the 2's are out. I have this expression du, like so. Now if I also speed here, I'm going to say 4 over 9, and then here just integration of these two terms, it will be u power 3 over 3 minus 5u, like so. And then I'm going to say plus c. Distribute this expression over, you're going to get 4 over 27 u power 3 minus 20 over 9 u plus c. What is u? Let's go back here. U is this expression. If you follow here, yeah, let me move this a little bit. Right, if you follow what I'm saying here, from here you can clearly see that u is actually equal to 3x plus 5 to the power half, square root of that. So I'm going to bring that one here, 3x plus 5 to the power half. So this is 4 over 27, 3x plus 5 to the power half, but I have the power of 3 outside, minus 20 over 9, 3x plus 5 to the power half, plus c. Simplifying up here, this is going to be 4 over 27, and then I have 3x plus 5 to the power 3 over 2, multiply those two, minus 20 over 9, and then I have 3x plus 5 to the power half plus c. That's our final solution to our third integral in this video. We have one more and then we are done. Let's go to the fourth one. Let me just keep track of the pages here. Page 5. Page 6 is where we stopped. We're starting on page 7 now. This is page 7. And our last integral is this one. Very simple to deal with. I am putting these integrals up just for practice. Someone may not have sufficient time to try and look for this information in textbooks and so on. Just by having access to these videos will go a long way in helping them prepare for exams. All right, so here now, again, we're going to use U-substitution. So maybe this one is simpler than the other one. So this is number 4, and we're saying the integral of x all over square root of x squared plus 1 dx. Now, what am I going to say here? I'm going to say let, same story, u squared be equal to x squared plus 1. And let's differentiate both sides. We have 2u du equals 2x dx. The 2's cancel. I have u du equals x dx. This integral then changes to the integral of, in the numerator, remember x dx is this one here, it must be that. So u du all over square root of, what do we have there? It's u squared, so over u squared. And this cancels that, so what do we have? We have the integral of u du over u, and these u's cancel, and I have the integral of 1 du, and this is just u plus c. Now what is u? From here you can clearly see that u is actually equal to square root of x squared plus 1. So therefore my final solution is going to be, if you allow me to come to this one as page 8, my final solution is going to be from there square root of x squared plus 1, that's u, and then plus c. That's my final solution to this integral here. Quite simple, and we haven't spent too much time evaluating it. All right, now final solution is that differentiate this, it must give you this expression here, this one. Okay, I'm going to stop here in this video. The next video I'm going to have, maybe next couple of videos, still on integration, very involving questions that I have lined up. In one video I will need one question only. It will take us maybe 25, just around 25 or 30 minutes to go through it with the explanation. All right, see you next time.